Hello.
Hi, can you hear us?
Dear colleagues, we are ready to start.
Yeah. Perfect. Hi.
So let's introduce.
Yeah, let me introduce you. This is David Gyulnazaryan from Impleon, and I'm Karl.
Karl Rabe from WoodenDataCenter.
Yes. We just, you might saw us yesterday, we won 2 awards, so we're very proud to be just now here. Today we talk a little bit about the state of data centers, into the data center world of increasing problems with large-scale data centers, which have been, facing opposition in Europe and in the US, also starting in Asia, and we want to create a new narrative for this because data centers cannot longer live alone as we call this as fortresses of data, but they have to be integrated islands in this. Those are just very quick Google latest opposition of last week, what is really happening, and we see an increasing growth with all the buzzwords you have on the show: big data, AI, HPC, cloud, you name it. So we propose a solution, and we're happy to propose it together with Frigil, but we didn't want to highlight a single aspect of this. We've come up with a complete hyperscale design that we want to contribute to the OCP. David is supporting this on the front of liquid cooling aspects, calculations, and I'm responsible for the construction part. So there's some highlights we want to go into today. For example, we're not going into the low carbon construction or deeply into the direct free cooling, but we want to look at microgrids and liquid cooling optimized for heat reuse. If the design is familiar, it's because we deliberately took idea from the Yahoo chicken cube for the ground space. And you can see right away, we're showing on this couple of options. There's not only traditional backup generators here, but also gas-based backup generation and battery-based generation. And we are comparing a very efficient adiabatic solution with standard dry cooler solution. That's why this is not looking symmetrical. So what is the premise? What we need to look on? We in the co-location space, we're still looking at rack densities of around 5 to 7 to 10 kilowatts. This is easily a 100 kilowatt rack. We have 2 different configurations. One we worked out together with Meta. The other one was just recently released on LinkedIn. But both of those are in the 90 to 100 kilowatt range, and they use lots and lots of GPU. They use lots and lots of NVM and links, and some of those servers are placed here. So the majority of heat is rejected through direct liquid cooling. We then put those in a double rack row concept in pods that either can be direct free cooled, or they can be assisted with heat exchangers, either row based or on the rack door front. So those are the options. So we try also to include the flexibility to not only run those very specific GPU and HPC loads, but rather be able to integrate storage and cloud-based computing as well. We want to talk a little bit about the way we need to rethink energy for large-scale data centers. With the integration, it's becoming increasingly hard for grids to integrate renewable energy. And data centers, on the other hand, propose a massive amount of flexible load that usually is unused. It just sits there, it's running with diesel. Hopefully it's already running with HVO. But we have the technologies available, and we have not in all countries, but in a lot of countries we have the opportunity to work with the utility to enable these loads to provide loads back to the grid. And the advantage of this is at a cost of 1 million per megawatt is that there are scenarios possible where the utility buys, builds, and owns and runs the microgrid, and you only have an SLA in terms of the energy. And all of a sudden you have a massive amount of primary load flexibility with battery storage and secondary load flexibility with gas backup engines. And this is really a game changer for grids and also for the importance of data center, that they have to be at grid important entities. We hear a lot today about heat reuse, and with liquid cooling, David and I, we look at a lot of liquid cooling cases, and we actually try to push the envelope and going higher in temperatures. We have found here a relatively moderate configuration, but if we go with an on-chip scenario or the hybrid scenario, we are enabling a direct output out of 60 degrees temperature, and if we add on heat pumps into this setup, we can easily go to nearly any heat grid up to 90 degrees. Something you want to add there?
Yes, I just want to add that we have two scenarios. First scenario is when we have air-cooled port with adiabatic air cooler, not liquid cooler. And in that case, we have only liquid-cooled chips. It is 48 megawatt. The temperature is 42 degrees inlet and 60 outlet. And second case, when we have door heat exchangers and we cool down also air part by adiabatic coolers. In this case, we have 34 degrees inlet and 60 outlet, and total capacity 60 megawatt. So we will have a look in the next slides, these two scenarios.
So we are here as independent consultants and data center designers, but we would like to invite you to look at a solution that we really have solved so much of the important sustainable solutions that we really like to work with them and to highlight some of those solutions. And the main thing in the discussion about data centers is nowadays also the water usage, especially in the UK. Last year we had the Google outage, and there is one important factor that we can cool adiabatic, but we don't have to have a high water tax, right? We created, in our scenario, a very high load per module. You see the picture of a module up top. We created a longer module that is even more capable, and it is very, very space saving. You see, or maybe you saw in the picture, but we see in the next slide that you can reduce the needed space for this by 40% by putting them on stilts. If you go to the booth, we invite you. You see large surfaces, large fans, very efficient setup. And that's why we like that, because a lot of those things that are different with those high load liquid coolings were already envisioned and solved with this Ecodry solution. David, you want to say something?
Yes, so this equipment can be driven in two modes. First one, when we are focusing on energy savings. And another one, when we are driving to make water savings. Both is possible, dependent from the climate, from the place, and cost of the water and energy. So we are flexible from that point of view. And here you can see how only by software, I'm in control of the adiabatic coolers, we can change the results of using of our equipment.
This is the mentioned small footprint setup. This is
yes, thank you, Karl. So the first case is for Italy, Bologna climate, where we have 60 megawatt data center. But from this 60 megawatt, only 48 megawatt is cooled by coolers. So there is one approach that we can have 38 degrees and cool down to 42 degrees from 60 by dry coolers without any water consumption. And installed power for dry coolers will be 1.5 megawatt, and we will have 24 units. So you will see below these 24 dry coolers. So in space, it's the same space as the data center itself. And another approach is using adiabatic coolers, where we have only 10 adiabatic coolers and covering the same 48 megawatts, but the power input for the fans will be just half megawatt. So it's 3 times lower. And if we look for the cost of water usage during the year, it is just 13,000, 14,000 euros per year. So it's nothing. At the same time, let's look for the capital investments for the dry coolers and for adiabatic coolers. In adiabatic coolers case, it is 30% lower. But there is also additional cost of covering this 1 megawatt additional power. And as we said before, 1 megawatt energy infrastructure cost is 1 million euro. So we should put additional 1 megawatt to the energy infrastructure. And in case of adiabatic coolers, there is no additional investment. And let's look next slide. Next slide is for the total liquid cooling. It's with air-cooled part also, and we have 60 megawatt. But 48 megawatts we still will cool down with dry coolers, and 12 megawatt where we need 20-25 degrees water, we will cool down by chiller with free cooling. So in this case, you see that we need even more space for the outdoor units. We need 18 dry coolers and 10 chillers, so 28 units. It is 2 times more than adiabatic coolers. And again, the power input for 60 megawatt will be 401 megawatt, and in case with adiabatic coolers, it's just 757. So the gap is 3.5 megawatt. And in this case, we see that we have savings on OPEX heavily. Instead of 1.1 million, we have just 1.3. And water consumption in money, it's negligible, so it's extremely low. But if we look for the CapEx, the chiller system with the dry coolers will be roughly for 2 million euro more. And plus on top of that, 3 million euros to cover this 3.5 megawatt power. So this is a comprehensive understanding of the cost of running system in our other traditional way. And next slide, please. And let's now evaluate what about VUE, what about the impact on the water consumption, environmental impact. So if we take 60 megawatt and have a look at the IT power, IT load during the year, and ratio between water on site and cubic meter divided by the energy IT load which is covered, we will get the factor 0.022. So that proves that our VUE is extremely low. It's not making any harm for the environment, and it's better to use the 11,000 cubic meter of water, but save a lot on energy side.
So to put this all together, we believe there is a way to integrate those data centers. We just thrown up a little bit of KPIs that we can think about when going to those really high density, really high load racks. The total power we see down up to 80%. The IT load, we can incorporate more IT load in this. The overall OPEX of this solution with the microgrid and the adiabatic cooler can be 70% lower. We have CapEx advantage of up to 60%. We lose a lot less surface for those large data centers that nowadays. And we have an extremely low water usage. Adiabatic is seen as evil, but we found a way to still make it work when it's applicable and it's liquid cooling ready to talk of a database. So with that, I'd like to invite you.
Yes, so we are ready for questions, and we are happy to answer all the questions. And if you have much more deep dive, you can come to the stand and see that unit in reality.
Yeah. Watch out for, talk to me and David, and watch out for the OCP specification. We will not only publish a data center design file, but also a large document explaining how we went from data center, from the rack configuration to the findings of using the adiabatic liquid.